Okay, this last section that we're going to cover is just basic graphs. Okay, these are the ones I want you to know. Without a calculator, you should know what these graphs look like. It's going to make your life a whole lot easier. And most of them we do know. Some we might need a refresher. Okay, so basic graphs you need to know, of course, mx plus b. We're all good in knowing that's a line with slope m, y-intercept b. So whatever it may be, looks like that. Of course, if it's just a constant, that is a horizontal line. Okay, and an x equals a constant is a vertical line. Okay. But we know this is, of course, a line. Now, absolute value of x, you should know, is a v. Okay, has a slope of 1, because that m is still correct. mx plus b, whatever's inside. But you have a slope of 1, but it's just a v. And what absolute value is really, this is the line y equals x. And everything that's negative gets reflected up. So this negative part just gets reflected up to the positive. That's what absolute value actually is. It takes the negative part, reflects it upwards. The positive stays the same. Okay. Now what we're going to do is transformations, because I know you've done them with trig this year with me. You did them with Mrs. Bybee with parabolas. That if we add 5, that shifts the v up 5. Subtract, it goes down. Now be careful if you subtract inside, because a lot of people, that's not down. Remember, that's the whole function is if you subtract, it moves down. This is actually going right. Remember our trig, it was negative c over b, okay, because it's the opposite of what you think. So subtracting within a function moves it right to, not left. It's the opposite of what you think, right and left. Another one you should know is a cubic. Now remember, a cubic can be really skinny, like this one. X cubed is just really skinny. But it can also be drastic depending on what's going on. Okay, we know that much. And if I want to be accurate, which we will when we're doing homework, I can pick points. 1 cubed is 1. 2 cubed, I should be way up here at 8. So actually I'm not very accurate here. Looks more like that. Okay, real skinny. Square root of x. This is a hill. This is one you may not really know. Square root of x is really a hill. So think about it. If I plot points. 0, I'm going to get 0. 1, I'm going to get 1. Don't pick 2 because you don't know the square root of 2 off the top of your head probably. 4, I'm going to get 2. 9, I'm going to get 3. So it actually just looks like a slow growing hill. What an absolute value. And there is a dot there. Okay, that is a closed circle. So that's what square root. Now, of course, I could move that up or down by adding. I can move it right or left. I could reflect it by multiplying by a negative. Okay, but you need to know the basic square root of x is just like a hill. Okay, x squared, of course, we know, parabola. And we can be very accurate with that, picking points as well. This is one you probably don't know. You have a square root of a constant squared and a perfect square variable. So they have to be perfect square. Perfect square minus a perfect square. Okay? This is a semicircle of radius a. So that's negative a, a, a. So hypothetically, if I had the square root of 4 minus x squared, that is a semicircle of radius 2. Okay? Now, if I have negative, that's the bottom half of the semicircle, not the top. Okay, because remember, negative reflects it. So this is one you probably did not know. Perfect square minus perfect square. That is a semicircle. Look how beautiful my semicircle is. Isn't that gorgeous? E to the x, we covered that. It's been a while. Remember, exponential, this is a very important one, grows. Okay, slowly, slowly. It approaches the x-axis down this direction and then grows rapidly. Remember, it actually goes through 1 on the y-axis, but it grows rapidly. Natural log of x is kind of its inverse. It's kind of a reflection. Goes down here. Looks like that. Now, if you're graphing on your calculator, it looks like it stops, but it doesn't. It keeps approaching that y-axis down there. So be careful. We have to know our calculators are not perfect. It looks like it stops, but it does not. It keeps going down. So this is natural log of x, e to the x. So any log looks like this, regardless of the base, and an exponential looks like this. expect you to know sine, cosine, tangent, cosecant, secant, cosecant, or cotangent. I expect you to still know those as well, and piecewise. We're going to graph a few of those. Okay, now to find intercepts, that might be a little bright. There's a quick way. We don't have to always get lines in slope-intercept form. Remember, to find the x-intercept, you plug in 0 for the y. And we did this with planes, because think about it. If I want to know the x-intercept, that is a point, something, 0. Something, 0. Something, 0. So if I'm on the x-axis, your y value is 0. That's why we plug it in and get a shortcut. Opposite is true for the y-intercept. Plug in 0 for x. Because if you're on the y-axis, your x value is automatically going to be 0. So we're going to graph this one, and I'm not going to get y by itself, which we did on Tuesday, but I don't need to. See how 5 and 2 both go into 10? I'm going to use my intercepts. So for my x-intercept, plug in 0 for y. I'm going to be left with 5x equals 10, or x equals 2. So I cross the x-axis at 2. My y-intercept, plug in 0 for x, I'm left with negative 2y equals 10. Y equals negative 5, so I cross the y-axis at negative 5. Now all I do is connect them. I don't need to know the slope to graph these. You just graph the intercepts and connect them. It's very simple. But I really only resort to that when these two numbers, these two coefficients go into this number nice and neat. Because if I get fractions, that's not very accurate. Okay, so I kind of only resort to it. If these two numbers do not go into this third one, I go ahead and get y by itself, plot my b, use my m to move up or down. But here's a quick shortcut that I can use intercepts. It may have been a while since we've done that with just lines. I know we did them with planes. Okay, so here's an absolute value, which I should know from my basic graphs is a v. Then I just have to analyze what's going on. Slope's still 1, that's m. Okay. Adding 2 moves that v up. It's going to shift it up 2. Subtracting 4 inside, remember it's opposite of what you think, that's actually moving it right 4. So instead of my v being at 0, it's going to be right 4 up 2. And then I just have that v with slope 1 and negative 1. And of course I'd use a ruler to be accurate. So there we go. I shifted it right 4 up 2. The slope is still the 1 and negative 1. Still a perfect v. We're not going to really mess too much with that, the slope. We could, but we're not going to get into it too much. 2x cubed plus 3. Now we know cubic is real skinny like this. But we're going to pick some points. It's going to be hard because this gets big kind of fast. Let's pick a few points. If I plug in 0, I'm going to get 3. If I plug in 1, I'm going to get 5. If I plug in 2, it's going to give me 8 times 2, 16 plus 3 is way up there. So I'm out of space for sure. Let's go to the negative. If I plug in negative 1, I'm going to get negative 2 plus 3, which is just 1. Plug in negative 2. Let's see, they'll give me negative 8, negative 16 plus 3. You probably have room on your graph paper. I don't. But again, negative 13. So down there somewhere. So we're just going to kind of sketch. We know it gets really skinny. Try your best. But pick a few points, as many as you can, to be accurate. We know the general shape is a cubic. Okay, and pretend that that's kind of a little messy there. But pick a few points to be accurate. Next one, 5 plus square root of x. Now we know square root of x is just a hill. We know it looks like that. Okay, shifting it up 5, it's going to look like that. But let's be accurate. If I plug in 0, I'm going to get 5. Plug in 1, I'm going to get 6. Don't plug in 2 because you don't know square root of 2. Plug in 4, I'm I'm going to get 2 plus 5 is 7. Plug in 9, I'll get 8. So we know it looks like this. So there's my square root of x plus 5. Just a hill shifted up. Good refresher here. 4 sine 2x plus 1. Of course, we know sine looks like this. That should be drilled into your brains. Remember, this is my amplitude. It stretches it to 4. This goes up 1. Remember, this changes the period. The normal period of sine is 2 pi. Remember, to find the new period, it's 2 pi over b, which in our case is 2 pi over 2, which is pi. So remember, I'm going to make 8 squares be pi. That makes that pi over 2. Same in the other direction. Oops, is that 4? No. Negative pi over 2. Negative pi. And I know I have to stretch up to 4. Actually, I'll end up going up to 5. So my sine wave, initially, real skinny here because it only goes up to 1. Remember, goes through 0, draws a pi. Looks like that. Then when I stretch it to 4, I'm going to have trouble seeing from way back here. I'm going to go all the way out there, down to 4 here, all the way up to 4 there. Down to 4 here. And then finally, everything goes up 1, including your zeros. I know that's kind of hard to see here. Whoops. 1. There's my zeros. There we go. There's my final graph. I know that color might be a little hard to see, but I just shifted up 1. This all should come back to us. If you need to review with that stuff, because I do expect you to still know how to graph those, remember that's chapter 7. It's where we graph sines and cosines pretty hard. Okay, I still expect you to know their domain, range, all that good stuff. Periods, how to change the period. 4 minus x squared. Now in general, we know this is a parabola. But this tells me it's reflected up 4, right? That's plus negative 1. So reflected up 4. So we know it's going to look something like that. But let's be accurate here. At 0, I know I'm at 4. At 1, I know I'm at 3. And we know it's symmetric. So negative 1, same thing. At 2, I'm at 0. Same with negative 2. At 3, I have 4 minus 9, so that's negative 5. Same with this way. And let's kind of go ahead and of course, you guys can do this a little easier than I can on the board. Whoa, missed that one. Let's try that again. Maybe. And make sure you have arrows on your parabola because it goes on forever. So try your best to make it look like a parabola. It's a little hard for me to do on the board. But once again, we know it's reflected up 4. So if you know your basic, we call them grandparent functions, or parent functions, depending on what book you ask. Parent functions that you know x squared is a parabola, you know absolute value is a v, you know cubic is that squiggly. If you know your parent functions, it's just a matter of reflecting them, shifting them, stretching them. Let's do this one. 9 minus x squared. This is not a hill. That's just the square root of x. Okay? This is a perfect square minus a perfect square, which is a semicircle. And its radius is 3, because remember that's its radius squared. So at 3 in all directions is the top half of the semicircle. If this was negative, that's the reflection. That would be the bottom half, but we don't have that in this problem. And of course I could add and shift it up, all that good stuff. We could reflect it. So That's a good one. Easy points right there if you remember semicircle. Okay, so here's a you try. You may pause it if you want, but I'm going to go ahead and work it. Okay, we know V is absolute value. This moved it down 2. This moved it left, because it's inside, so that's what we think. So down 2, left 3, that's where my point's going to be. And instead of reflecting up, I'm going to be reflecting down. Voila. It's reflected. Okay. Let's do some refreshers on piecewise. I know we just covered this, but a few of you are still pretty weak. This is a line. B is 3. M is -1. So up at 3, you know you're going to be going down 1, but you only want it less than 0, so you only want this part. That's actually an open circle, right? Because you only want 0 and below. This is a parabola shifted up 1, so we know it looks like this. Let's pick some points to be accurate. So at 0, you know you're at 1, and that is filled in. 1, you know you're up at 2. 2, you know you're up at 5. And then at 3, you're up at 10. So the second half is going to look like that. Because you only want x is bigger than 0, so don't draw the other half of the parabola. Another piecewise, just to make sure we have these down, because piecewise are a huge topic of calculus. It's in about every section. Okay. So once again, line. Okay, it's 5 and then up to, so it looks like this, 5, 1. But I want it from -3, so I'm going to go ahead and plug in -3. If I plug in -3 at -6 plus 5, so I know it starts at -1. Okay, so at -3, I know I'm at -1, and it's an open circle. Now you know the slope is 2, so just follow that, down to 1. That has a slope of 2. I kind of cheated there. I didn't have to draw the whole line. You could have draw the whole line and then erase it. But I know that at -3, it's going to be at -1, and I just know the slope. Cubic, we know at -3, that's way down there. I don't really have enough room for that. Because -3, when I plug it in, I get -27, clear down there. But at -2, I know I'm at -8. -1, I'm at -1. 0, 1, 8. So I know that's an open circle, and I know we're just going to kind of bluff it. That down there, clear down there, is a closed circle. We know that, but I don't have enough room for that. I won't give you one like this on a quiz where you don't have enough room. Okay, the next part is a V moved right. So it'll be V moved right at 5. So it looks like that. But be careful, we only want it past 2, so don't go past 2. So here's 2, close it up. You only want 2 past. There we go. Once again, yours will be a little neater than it is for me to do on the board. It's harder to graph on the board. Especially that cubic doesn't look too curvy, but. Okay, now let's review even and odd functions. This is a very important one. They like to ask this occasionally on the AP test. Remember, an even function is even if and only if f of x equals f of -x. Meaning if I plug in a number, 2, and I plug in its opposite, you get the same thing. That should make sense. Guys, think about it. Here we know parabola is even. It's symmetric about the y, okay, which I think is what I have now. Symmetric about the y. Remember, those are even functions. So parabolas, your cosines, what else we have? We have absolute value. Those are all even functions. Should make sense. If I plug in 2, I get 4. And if it's symmetric, if I plug in -2, I better get the same thing. Now, odd means it's symmetric about the origin. And that means that if I plug in a number, 2, and I plug in its opposite, they're not equal, they're different signs. So one of them's negative. So think of your odd functions. The most obvious one is your cubic. Also tangent, sine. Okay, a lot of those are odd. So if I plug in 2, I'm going to get 8. If I plug in the opposite, I'm going to get the opposite, negative 8. So they should kind of be a reflection of each other, but just the opposite direction. Okay? You shouldn't need a graph to determine even and odd. Okay? It helps us. We know what's even and odd by looking at a graph, whether it's symmetric about the origin or the y. However, we should be able to determine it algebraically by just plugging in. Okay? So that may be hard. Let me change the color. We're going to classify functions as either even, odd, or neither. And yes, I see I have a typo there. Functions. All right, so just 2 tangent x. Well, we know from the graph, we know the answer is odd. We know tangent is odd. Stretching it by 2 is not going to affect that. But here's how you show it. So pick a number. Don't pick 2 in this case. Don't pick 1 either, because you don't know what tangent of 1 is. Pick something you know. So I'm going to pick f of pi over 4. Okay? Which give me 2 times tangent of pi over 4. Tangent of pi over 4 we know is 1. So I get 2. Now I want f of negative pi over 4, which is 2 tangent of negative pi over 4, which is the bottom part of the unit circle. So that's negative 1. I get negative 2. Therefore, it's odd, because I have the same answer but different signs. 6 plus 2x squared. So pick a number. I'm going to pick 1. It's the easiest number. Plug it in. I get 6 plus 2, which is 8. Plug in its opposite. I'm going to have 6 plus 2, because negative 1 squared is still 1, which is 8. So since I have the same answer, that is even. E to the x. Well, f of 1 is just e, correct? F of negative 1 is e to the negative 1, which I hope you remember is 1 over e, right? Takes it down. Which obviously that's a fraction. This is not, really. Okay, so they're different values. I don't need a calculator to know exactly what the values are. I just know they're completely different. That's like 1 divided by 2.718. That's 2.718. So very different numbers. So therefore, neither. Okay. So your homework is a handout. Of course, they're on graph paper. They are accurate. If you need rulers, come and get one. Once again, if you have any questions, make sure you ask. Okay, make sure you ask. There will be a quiz Monday. We have a practice handout Friday and a quiz Monday.